In this video, we'll talk about the segment addition postulate, which is one of the basic understandings on which a lot of other geometry is built. So first of all, what's a postulate? A postulate is a statement accepted without proof. We all agree that it is true. For example, there's a postulate that any 2 points are always collinear. And it's the base on which we're going to build much larger ideas. So the segment addition postulate says, if A and B are points, and a C is between A and B, then AC plus CB equals AC. Let's unpack that. Let's start by thinking if A and B are points. So here are our points A and B. Now, what does it mean that C is between A and B? Well, in geometry, it means something very, very specific. It means it's on the segment connecting. So C is on the segment connecting A and B. So here's segment AB, and here's C. What the segment addition postulate says is that C splits that segment up into two little segments. Imagine taking a big stick and breaking it. What the segment addition postulate says that if you put those two pieces together, you get the same length as the original segment. So in other words, that AC here, this length, is equal to the length plus the length of CB gives you the length of the whole entire segment. Let's look at a couple examples to unpack that a little bit. Make that a little bigger. All right, so first one, we're going to find a missing length here. When you are doing these problems, I want you to start with the original statement of the segment addition postulate applied to this example. Here's what I mean. What I have here is I have point R in between points Q and point S. So what segment addition postulate tells me is that QR plus RS is equal to the whole segment QS. And I do want to see that statement written down from you with just the letters of the points, just the names of those distances. And then let's substitute. I don't know what RS is going to be yet, so I'm going to give it a variable. Let's call it X. So QR, let's see, that's 11 plus whatever RS is. QS, we're told, is 17. That's what this number down here means. And now I have an equation I can solve. So I have started with my general statements. I've gone on to substitute. And now I'm going to solve. I'll subtract 11 from both sides to get that X is equal to 6. And that's the length I was looking for. Another example. So here's an example where we're not giving the diagram. We have all these little symbols and letters, and that can be hard to keep straight. So let's start by noticing a couple of things here, and let's draw a diagram. So it tells us that points A, B, and C are collinear, and we know that point B is between A and C. So that means B is on the segment connecting A and C. So let's just get a picture going here. So here's A and C. We'll put B on here somewhere. Now let's label the diagram. We're told that AC equals 13. So it's 13 all the way along. We know BC is 2x plus 26. And we know AB is x plus 23. So again, let's start with the general statement using just the names of the points. So the first little stick is AB, plus the second little stick is BC, and the whole big stick is from A to C. So there's my general statement. Now let's substitute. AB is x plus 23, BC is 2x plus 26, and AC is 13. So I made my general statement, I substituted, now I'm going to solve. So I'm going to gather my like terms on the left. So x plus 2x, that makes 3x. 23 plus 26, let's see, that's 49. So I have 3x plus 49 equals 13. Now I've got to subtract. I'm going to take that 49 over to the other side. So let's subtract 49. So 3x equals, let's see, that's 36, negative 36. So we're going to divide both sides by 3 to get that x equals negative 12. So we wrote the general statement, we substituted, and we solved. I want to give you one more piece of vocabulary before we close here. Segment bisector. So if a line or a line segment intersects a segment at its midpoint, remember midpoint? We say it bisects the segment. So bisects. There are a couple, if you break that word down, you know bi means two. Sect, think like dissect, cut up, so cut in two. It bisects the segment, means it cuts the segment into two equal pieces. In other words, here, if our line CD bisects segment AB, that means that segment AC is congruent to segment CB. Means AC is equal to CB. Those two distances are the same. So let's look at an example. Let's say again, DC bisects BA, and AC is 2x plus 1. Let's write that, 2x plus 1, and CB equals 5x. We're trying to find the value of x. Now, when we were doing segment addition postulate, we would have added those two pieces together to get the length of the whole long segment. But here, I don't have the whole segment. All I know is that DC bisects AB. What that means then is that these two segments are equal. So I can say that with an equation. I can write 2x plus 1 equals 5x, and then we'll solve. I'll subtract 2x off both sides to have 1 equals 3x. Divide both sides by 3 to get that x is equal to 1/3.